Aloha, my name is Dr. Francis Sakai Kawada, and I am a lecturer of chemistry at Chaminade University. I originally graduated from the Big Island at Waiakea High School and continued my university work at University of Hawaii at Hilo, and then my graduate work at UH Manoa. So let's talk a little bit about what you can do as a chemist. So other than your typical route of teaching chemistry or even going into research in chemistry, the list is pretty endless. Pretty much everything that you see around you has to do with chemistry. So in this case, we're going to be talking a little bit about food science. So today we're going to look into the chemistry of making butter, and you really just need two things for this. One is a jar with a tightly sealed lid, and two is heavy whipping cream. Pour it straight into the jar. Don't really need to measure how much. Make sure you tightly seal it because you don't want your cream spilling all over the place. All we're gonna do is just pretty much shake. So an important thing about being a scientist is making sure that you're observing what's going on. So it's not only what you see, but also what you can hear and feel in this case. And right now, you can't really see it, but you can hear that it sounds different. It doesn't sound like liquid just sloshing around in the jar. So we're not going to take a look just yet, but we're going to just monitor what's going on right now. So I don't hear anything right now, so we're going to take a look, and lo and behold, we have whipped cream. But of course, we're not looking into the chemistry of making whipped cream. We're looking into the chemistry of making butter, so just keep shaking. You can kind of notice we have sound again. What's happening in there is we are creating butter, and this liquid is going to be the excess buttermilk that's being formed in the process. Some time has passed. You can hear that there's not as much liquid going on, and how it feels, you definitely feel something hitting the sides and the walls of our container. And yes, we definitely have butter in there. We have a big solid glob of butter. Now what we're going to do is a process called decanting, where we pour off the liquid buttermilk and save all of the solid butter. Before we save this as butter, make sure to wash our butter. We want to take out as much of that buttermilk as possible. If we don't, our butter is going to end up going bad very quickly. So we're going to just get some cold water, swirl around our butter a little bit, get out any of that buttermilk. And in the process, you can pour off all the excess liquid. And we'll just end up doing that a couple of times. There you have it. We have butter. Let's go into the science of making butter. So again, we added our cream into our jar. As we shake it, we start introducing air into our jar, into all of the fats that are in there. In our cream, there is this thing called an emulsion, which is going to be two liquids or more that aren't mixable. We're shaking it, we're introducing force into it. The fat within our cream is separated by these little lipoproteins, which are going to be going around our fats. As we shake it, we're going to end up breaking up all of those, or popping all of those membranes. As you're shaking it more, and remember when we start off with whipped cream, right? We started to hear this sort of solid forming as we shook it more. And because the fats like to clump together, what's going to end up happening is they're going to clump together, and that's how we have our separation of our buttermilk and our butter. Okay, so now that you learned how to make butter, I'm going to put it on you guys to be able to experiment with it. Try different things out, whether it be changing the temperature. What happens if it's colder? What happens when it's warmer? Does it take longer? We use heavy whipping cream. What happens when you use half and half? Looking at the different fat content of our milk product and whether or not we can form butter in the first place. And things such as the time it takes, or even how hard you're shaking it. Make sure you keep a notebook. Write down the different variables that you're testing, write down your observations, and you too can also be a scientist.